This is ChoWorld. This is not a recommendation to buy or sell. Let me talk about the details of this Joby test. Currently, Joby is conducting FAA tests while flying for about 23 to 24 minutes, adding around 2 minutes per day. The key point of the recent adverse weather test is not horizontal flight, but vertical landing. It showed whether the aircraft could maintain balance and land safely even when some propulsion units failed under conditions made worse than ordinary bad weather. The fact that 2 out of 6 propellers were turned off means that, by number, about 1/3 of the propulsion units were inactive. Looking at it in more detail, the actual test took place in Marina, California, where the 6 propeller aircraft took off vertically in fog and rain. During the flight, they simulated the failure of one propeller, and to maintain balance, the opposite propeller was also stopped. In the end, with 2 out of 6 propellers stopped, the aircraft maintained a hover for about 2 minutes, using only the remaining 4 propellers. It then succeeded in a vertical landing, showing that it could land safely even in an emergency situation. This test was a combined safety verification involving adverse weather, propulsion system failure, hovering, and vertical landing all at once. The location was Marina, California in the United States, and the weather consisted of dense fog and rain. In Joby's 6-propeller eVTOL, they simulated the failure of one propeller during flight. To maintain balance, the opposite propeller was also stopped, leaving 2 out of 6 propellers stopped and only 4 operating. In that condition, the aircraft hovered for about 2 minutes and then successfully completed a vertical landing, confirming that safe landing is possible even when part of the system fails. Turning off the opposite propeller when one propeller fails is a control strategy to rebalance the aircraft. If one propeller fails, thrust on one side disappears, which can cause the aircraft to tilt or rotate. So by stopping the opposite propeller or adjusting its output, the aircraft restores left, right, and diagonal balance and stabilizes its attitude using the remaining 4 propellers. In its official materials, Joby has explained that the aircraft has 6 independent propellers and 4 independent battery packs, and that if one propeller station has a problem, it can continue flying even with the diagonally opposite station turned off. Joby has also explained that each propeller has 2 redundant motors and that each motor is connected to a separate inverter and a separate battery pack. The fact that it hovered and landed vertically using only 4 propellers is especially important. During forward flight, the wings generate some lift, so there is relatively more room to respond to propulsion system failure. But during hovering, the aircraft depends almost entirely on propeller thrust, and during vertical landing, altitude and time are limited, leaving little room for recovery. Hovering in adverse weather also verifies visibility, humidity, sensors, electrical systems, and control stability together. Therefore, the fact that Joby hovered and then landed using only 4 propellers is strong evidence of its fault tolerance. To summarize this part, the Joby aircraft stably performed the entire process from takeoff to hovering and vertical landing using only the remaining 4 propellers. Joby also announced that in tests at Edwards Air Force Base, it simulated various failure scenarios such as motor shutdown and battery shutdown, and that even with only 4 out of 6 propellers operating, the aircraft could continue flying safely and perform a controlled vertical landing. The key point of this test is that it completed that difficult phase in adverse weather using only 4 propellers. The fact that there was not only fog but also rain made this test even more difficult. Rain verifies the waterproofing of electrical systems, propeller efficiency, effects on the aircraft surface, and sensor stability. Fog verifies piloting and air traffic control procedures under limited visibility, as well as navigation stability. On top of that, stopping 2 propellers verified the propulsion system's failure response capability, while successful hovering with 4 propellers and vertical landing confirmed remaining thrust, attitude control, balance maintenance, and the landing capability that increases passenger survivability. This test was not simply a flight in adverse weather, it was an extreme test that simultaneously verified adverse weather response, propulsion system failure response, hovering stability, and vertical landing capability. What the FAA looks at most importantly in eVTOLs like Joby is not whether they fly well under normal conditions, but whether they can keep people safe even when failures occur. The FAA finalized separate special airworthiness criteria for Joby JS41 suited to its powered lift design. These criteria combine existing airplane and rotorcraft standards with requirements tailored to Joby's aircraft. FAA standards include a requirement that hazardous propeller effects from the propeller system must be predictable at an extremely low probability. This test can serve as a strong answer to the FAA's core questions: response to a single failure, propulsion system redundancy, and continued safe flight and landing after a failure. This test is a very important key piece of the puzzle, but it does not represent the entire FAA certification process. The FAA reviews not only the aircraft itself, but also battery safety, flight control software, structural strength, repeated operational durability, maintenance systems, pilot procedures, airspace, and operational approvals. Therefore, the accurate way to describe this is that the test shows Joby strongly passing one of the core challenges of FAA certification. Structurally, Joby has a different safety philosophy from conventional helicopters. A typical helicopter relies on an engine and mechanical transmission system centered around the main rotor, and it is an aircraft designed around preventing critical systems from failing. Joby has 6 distributed propellers, 4 battery packs, electric propulsion, fly-by-wire, and redundant flight control computers. In other words, Joby is an aircraft designed to rebalance with the remaining systems and land safely even if some propulsion units fail. If helicopters are centered on failure prevention, Joby is centered on fault tolerance and safe landing. Since Joby is still just before commercialization in Dubai and does not yet have large-scale commercial passenger operation data, it cannot be statistically confirmed exactly how many times safer it is. The US helicopter industry's 2024 fatal accident rate was reported at 0.44 per 100,000 flight hours, while the total accident rate was reported at 2.99 per 100,000 flight hours. This is approximately 4.4 times 10 to the minus 6 per hour, or roughly 1 fatal accident per 227,000 flight hours. However, FAA design standards are closer to the probability of catastrophic failure in aircraft design, while helicopter fatal accident rates are real-world statistics that include all operational accidents such as pilot error, weather, collision, and maintenance issues. Therefore, simply dividing the numbers and saying it is 440 times safer would be an exaggeration. Combining the structure, certification goals, and failure response tests, safety can be estimated from different perspectives as follows. If we compare only aircraft structure and failure response, Joby may have more than a 10 times advantage over helicopters. If early commercial operations are estimated conservatively, it may be 2 to 5 times safer than helicopters, and for overall commercial operations, it may be 3 to 10 times safer. In a long-term ideal scenario, it could be more than 10 times safer than helicopters, but there are not yet definitive statistics that can confirm this. Ultimately, the real meaning of this Joby test is not simply that it flew in the rain, but that even in adverse weather, with 2 out of 6 propellers shut down, it endured on the remaining 4 and landed safely. Please subscribe and like, and I hope you have a fundamentally happy day today as well. Thank you.